Vectors for two-dimensional motion. In this video, we will have a look at multiplication of vectors. The first kind of multiplication of vectors is called scalar dot product. When you multiply two vectors and the resultant quantity is a scalar quantity, then such a product is called as scalar dot product. For any two vectors A and B inclined at an angle theta, A bar dot B bar will be equals to magnitude of A bar into magnitude of B bar into cos theta, or simply AB cos theta. Geometrically it is represented as two vectors A bar and B bar inclined at an angle theta, then scalar projection of A on B, that will be A cos theta. Hence the scalar dot product will be AB cos theta or A cos theta into B. Practically speaking, when a child pulls a toy with the help of a string, then the force is acting along the string, but the displacement is along the positive x-axis. If the force is acting along an angle theta, then the component of the force along the displacement is responsible for the work done, and that component in this case will be the cos theta component. Hence the work done is given by force into displacement F bar dot S bar, that will be equals to Fs cos theta. Next, let us have a look at properties of scalar product. The first property is that scalar product is cumulative. That means A bar dot B bar will be equals to B bar dot A bar. The direction here does not matter, since the resultant quantity will be a scalar quantity. Next one, if A bar is perpendicular to B bar, that means if the angle between the two vectors is 90 degree, then AB cos theta will be equals to 0. Now the vectors along x, y and z axis are I cap, j cap and k cap. Hence I dot j will be equals to j dot k will be equals to k dot I, and that will be equals to 0, since all these unit vectors along x, y and z axis are mutually perpendicular to each other. Next one, A bar dot A bar is nothing but magnitude of A bar into magnitude of A bar into cos theta. The angle between A bar and A bar is 0 degree, hence cos 0 is 1. So A bar dot A bar will be simply A square. Hence I dot I will be equals to j dot j will be equals to k dot k, and that will be equals to 1. The last property, if any vector A is given by A1 I cap plus A2 j cap plus A3 k cap, and any vector B is given by B1 I cap plus B2 j cap plus B3 k cap, then A bar dot B bar will be represented as A1 B1 plus A2 B2 plus A3 B3. Now this you can directly simplify when you multiply A bar into B bar by simple multiplication, where the result of I dot I will be 1 and I dot j and I dot k will be equals to 0. So the resultant will be of the form given here. The properties mentioned here are quite easy and are mostly based on value of cos theta. You don't need to mug up the properties, just try to understand the concept that A bar dot B bar is nothing but AB cos theta, and the value of theta has given rise to the properties. Next in multiplication of vectors is vector cross product. Vector cross product is when you multiply two vectors and the resultant is also a vector quantity. Mathematically, A bar cross B bar will be equals to AB sin theta into n cap, where n cap is the unit vector along the direction of the resultant vector. and the magnitude of the resultant vector is given by simply AB sin theta. Geometrically speaking, for any two vectors A and B inclined to each other at an angle theta, if you have the resultant parallelogram, then area of that parallelogram will be the magnitude of A bar cross B bar. That will be nothing but AB sin theta. Since the altitude of the parallelogram is given by A sin theta, the direction of the resultant vector is given by the right hand thumb rule. It is represented as, for vectors A and B, the right hand is curled around vector A along B and the thumb gives the direction of the resultant vector of A cross B. Next we shall discuss properties of vector product. The first property of vector product is that vector product is non-cumulative. That means A bar cross B bar will not be equals to B bar cross A bar, but A bar cross B bar will be equals to minus of B bar cross A bar. Since the resultant quantity of A cross B is a vector product, hence if you change the directions of A cross B to B cross A, then the direction of the resultant vector will also be reversed. Therefore, for unit vectors along x, y and z direction, I cap, j cap and k cap, we have I cross j will be equals to k, but j cross I will be equals to minus k. J cross k will be equals to I, but k cross j will be equals to minus I, and similarly k cross I will be equals to j, but I cross k will be equals to minus j. Now the simple way to remember is that if you move from I, j to k, then the cross products are positive, and if you reverse the direction and move from k, j to I, then the resultant will be the negative quantity. Next property states that if A bar is parallel to B bar, then AB sin theta will be equals to 0, since sin 0 is 0. Hence, I cross I will be equals to j cross j will be equals to k cross k, and that will be equals to 0. Now, if for any vector A equals to A1 I cap plus A2 j cap plus A3 k cap and B equals to B1 I cap plus B2 j cap plus B3 k cap, then magnitude of A bar cross B bar can be found by solving the matrix where I cap, j cap, k cap will be the first row, then A1, A2, A3 second and B1, B2, B3 will be the third row. As discussed earlier, for any two vectors A and B inclined to each other at an angle theta, then the resultant parallelogram, when solved, the area of that parallelogram will be given by the magnitude of A cross B, and half of A cross B will give the area of the triangle enclosed by vector A and vector B. Finally, to easily remember, keep in mind that for scalar dot product and vector cross product, the trick lies in the name itself, scalar dot product. So if there is a dot product, the resultant quantity will be a scalar quantity, and vector cross product. So if there is a cross product, the resultant quantity will be a vector quantity. Therefore, A bar dot B bar, the resultant will be the cos theta component, and for the cross product, the magnitude, the resultant will be the sin theta component. Also remember, for vector cross product, you can use the right hand thumb rule to find the direction of the resultant vector. The rest of the properties for both of them are mostly dependent on whether here we have the cos theta or sin theta, and based on that you can easily solve any given question. Also keep in mind that scalar dot product and vector cross product are very important in understanding various other concepts of physics.